Hello friends, welcome back. In this tutorial we will study a theorem. Now this theorem states that if there is a pushdown automata M1 which accepts the language L by empty stack, then the same language L is accepted by some pushdown automata M2 by final state. Now let us prove this theorem. Suppose there is a pushdown automata M1 which accepts the language L by empty stack. Now this M1 is described by a 7 tuple. M1 doesn't have any final state. Q1 is its initial state. Z1 is stack start symbol of M1, delta 1 is its transition function, and Q1 is the set of all states of pushdown automata M1. Now we have to construct a pushdown automata M2 that accepts the same language L by final state. Now M2 is defined by this 7 tuple. M2 will contain all states of M1 and two other states Q0 and QF, where Q0 is the initial state of M2 and QF is the final state of M2. M2 contains all stack symbols of M1 and one more stack symbol Z2, which is the stack start symbol of M2. Input symbols remain same in both M1 and M2. Now let us look the transitions of pushdown automata M2. Now there is an empty move in M2 by which M2 jumps from its initial configuration to the initial configuration of pushdown automata M1 without reading any input symbol. Then all transitions of M1 are included in M2. Now suppose there is a string W which is accepted by pushdown automata M1. Then what will happen when pushdown automata M2 will read this string W? First of all, pushdown automata M2 will jump to the initial configuration of M1 from its initial configuration without reading any input symbol. Now this string W is accepted by pushdown automata M1. So on reading this string, M1 empties its stack. Since all transitions of M1 are included in M2, M2 will reach in this configuration. After reading all symbols of a string W. Here Q is some state of M2 which is also in M1. Now see, we have added transitions in M2 for all states Q of M2 which are also in M1. We have added this type of transitions for all states Q of M2 which are also in M1. In Pushdown Automata M2 we have added this type of transitions. So after this, M2 will jump to its final state from this configuration because we have added this type of transition in M2 for all states Q of M2 which are also in M1. So what will happen? M2 will jump to its final state. So the string W will also be accepted by Pushdown Automata M2. M2 will accept this string W by final state. So Pushdown Automata M2 will accept the language L by final state which is accepted by M1 by empty stack. It would be more clear after this example. Suppose there is a Pushdown Automata M1 which has these transitions. Q is its initial state, X is its stack start symbol. M1 accepts the language L by empty stack. Now we have to construct a Pushdown Automata M2 which accepts this language L by final state. Let X0 is stack start symbol of M2. M2 will contain all stack symbols of M1 and one more stack symbol X0. M2 will contain all states of M1 and two more states Q0 and QF, where Q0 is the initial state of M2 and QF is the final state of M2. Input symbols remain same in both M1 and M2. Now see the transitions of M2. There is an empty move in M2 by which M2 will jump from its initial configuration to the initial configuration of M1. After this, we have included all transitions of M1 in M2. For all states of M2 which are in M1, there will be an empty transition for stack start symbol X0 of M2 to its final state QF. In M1 there is only one state, that is Q. So there will be only one transition in M2 of this type. Right? Now this M2 will accept the language L by final state. Thank you very much.